A 4-story wall of water that only rises once in 1,300 years was recorded off the west coast of Canada. Some people blame waves like this for disappearances in the Bermuda Triangle. Rogue waves can get strong enough to sink container ships and oil rigs. The Canadian water monster didn't hurt anyone, but it did become a sensation. And it looks like we're about to see even higher and more powerful rogue waves in the future. The team of Marine Labs, the company that operates the buoy that got caught in the Ucluelet wave, couldn't believe the data they saw. A huge force came out of the blue, pulled the buoy down, and then set it up to a peak before taking it even deeper. They thought it must be a rogue wave, so they sent the data to a scientist at the University of Victoria who specializes in these beauties. They analyzed the data and confirmed it was indeed not a technical mistake. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Scientists have reported seeing giant waves coming out of the blue for centuries, but no one really believed them. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got in a terrible storm and saw several waves over 98 feet tall. It's almost as tall as a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and shared what they saw. But back then, scientists were sure waves couldn't be taller than 30 feet. Everyone took their story as a tall tale. Pun intentional. Over a century later, a cargo ship, the MS München, mysteriously disappeared. People believed it to be unsinkable, just like the Titanic, so it was a real shock that all that was left of it was one lifeboat. When experts analyzed the damage, they concluded that it must have been hit by a wave that was around 65 feet high. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppner wave, or the New Year's wave. This monster on the North Sea that was 84 feet tall hit the Norwegian gas platform Doppner on New Year's Day. It was twice larger than the wave surrounding it. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. The wave wasn't like any other type of wave they'd studied before. So they had to admit rogue waves were real and gave them an official definition. It's a wave more than twice as tall as others around it. It can pop up lightning fast in a stormy sea, or show up out of nowhere in calm waters. These waves have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters trying to do their job. In 2007, America's National Oceanic and Atmospheric Administration made a list of 50 historical maritime tragedies that were most likely caused by rogue waves. Some of the events on the list happen not in the open water, but in lakes. Lake Superior has something that's got the name Three Sisters. It is a series of 3 large waves, one after another. The second wave covers the ship's decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the freighter Edmund Fitzgerald in 1975. There are 2 main theories trying to explain how rogue waves happen. First, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. When these waves cross paths, they team up and become stronger to turn into a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they exchange some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and put in a math model that would create a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but there is a huge progress in this direction. Scientists from the University of Melbourne went on an expedition to Antarctica and found out that strong winds play a big role in the creation of rogue waves. It looks like they're caused by a mix of strong winds and the random way waves move and interact with each other. This idea was tested in labs before, but now they've proven it happens in real oceans too. To study these waves, the scientists use special 3D cameras. These cameras work like human eyes, taking lots of images in a row to create a detailed 3D picture of the ocean surface. It showed that rogue waves happen more often when waves are young, which means they're just starting to form and are more affected by the wind. When strong winds blow over young waves, they make the waves taller, longer, and faster, but not evenly. Some waves steal energy from nearby waves and grow much bigger, which is how rogue waves form. The scientists noticed these giant waves happened about once every 6 hours. They recorded no rogue waves in calmer seas, when the wind doesn't have as much influence. Scientists are concerned that rogue waves may happen more often in the future because there's more energy in the atmosphere and ocean. It looks like rogue waves can be much more powerful than scientists ever thought. They managed to create the famous Doppler wave in a lab for the first time in 2018. This helped them study these mysterious waves up close and showed that their secret is in how they form. We think of waves rolling gently on a beach, but the waves in this study happen in open water when waves from different directions meet. When waves come together from far apart directions, they push the water upward, creating what's called a partially standing wave or a crosswave. This can happen when two seas meet, or when wind directions suddenly change, like during a hurricane. The study found that the bigger the angle between the meeting waves, the taller the crosswave becomes. Normally, when a wave breaks, it forms a white foamy top, and that's where it stops growing. But if a wave is formed by water coming from many directions, it can keep growing even after breaking. These special waves can grow to be twice as steep while breaking, which is already much bigger than normal waves. And if you add up all the growth from waves coming together, they can become 4 times steeper than what anyone thought was possible. This discovery could change the way we build things, like wind turbines or oil platforms in the ocean, to make them safe. Right now, many designs don't fully account for these huge multi-directional waves. Now, they seem to have a lot of similarities, but rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Dropner on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beasts may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of three large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These three sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are two main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either, but putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters also have the power to move huge logs, which carries another hazard. Now, forget about the Kraken and monsters from the deep. I know, it's hard, but try. And you can forget about the Bermuda Triangle and other marine anomalies. They are nothing compared to rogue waves. Giant walls of water that suddenly appear and just as suddenly disappear on the sea surface. The destructive power of this phenomenon remained a mystery to humankind for a long time, but it appears that scientists have solved this secret. A rogue wave is a wave that exceeds at least twice all the surrounding waves. If you imagine the world ocean like a video game, then ordinary waves are your opponents. But the rogue one is a super boss. For centuries, hundreds and thousands of ships have gone missing during their voyages. People have made up a lot of legends about what was the cause of marine disasters. Sea monsters, underwater anomalies, mermaids? But today, scientists are increasingly inclined to believe that rogue waves are the main cause of unusual shipwrecks and missing ships. Some believe sailors' stories about anomaly waves, while others didn't. But no one could prove their existence. However, everything changed in 1995. When a giant wall of water 85 feet high collapsed on an oil production platform off the coast of Norway. The waves around this monster were 39 feet high. In other words, the monster wave was about the size of a 9-story building, and the neighboring ones measured about 4 floors high. The oil platform wasn't destroyed, but the wave showed it could cause considerable damage to any buildings. Immediately after that, people began to study the phenomenon of rogue waves. However, in the beginning, instead of answers, scientists got even more questions. So, what's so mysterious about this phenomenon? We know how ordinary waves work. What's the problem with finding out the nature of rogue ones? Well, in fact, the difference between them is huge. Ordinary coastal waves are very predictable. They form because of the wind and the uneven landscape of the seabed. Depending on the depth, terrain, distance to the shore, and wind strength, the size and speed of the wave increase. These waves are safe. If they're not big, you can surf. If they are big, then you'll see them in advance and run out of the water, like me. Rogue ones, unfortunately, are almost unpredictable. They can appear suddenly, even during a calm sea. They appear not only on the coastline, but also in the open ocean, like a high-water cliff. The conditions for the appearance of these monsters are very chaotic. When several waves combine their energy into one, it creates a rogue wave. But this process cannot be predetermined or predicted. How is this energy formed? How is it released? And how much of this energy is needed? The questions are too complicated. Now, to try to figure it out, you can place a special buoy with sensors that scan wave data in the water. Then, you need to wait for the rogue wave to appear. And you don't know if it's going to happen or not. Fortunately, it happened off the coast of Vancouver Island. This monster, which was named the Ukulele wave, was 3 times the size of the surrounding waves and had a height of 58 feet. Proportionately, it was one of the most gigantic rogue waves ever recorded. And do you think that buoy with sensors helped to determine the nature of rogue waves? Of course not. It just showed the wave's data. In order to solve the mystery, a group of scientists from the University of Melbourne went to Antarctica, and this time they managed to find something. They brought the most modern equipment for studying weather conditions in water. They installed powerful stereo cameras on the icebreaker SA Augulus II and obtained three-dimensional images of the ocean surface. Now, observations showed that the formation of rogue waves began when small waves were most susceptible to wind. That is, waves of varied sizes and directions meet the wind, which makes several small waves combine with one large one. It grows faster using this received energy. This is not just a combination of waves, but also their physical effect on one another. Scientists call this nonlinear effects. To get closer to the solution, the scientists also used the fourth-order Stokes theory, which speaks about more complex interactions of waves and their energy accumulation. The theory didn't help much, but it made the whole study more strange. Scientists realized that small waves fed off one another. Then some waves became bigger than the rest and took away all the energy. This process is called modulation instability, and it explains why rogue waves appear so suddenly, as if out of nowhere. Still, scientists admit that even this information isn't enough for them to fully explain these giant waves. Now, long story short, oops, too late, the wind pushes younger waves together, causing them to grow higher and increasing their speed. One wave steals the energy from the rest, and boom! A giant rogue wave appears, looking disproportionately huge compared to the others. It hits a boat, an oil rig, or the surface of the ocean and spills out all that energy. And that's it, silence again. The existence of such a phenomenon has convinced scientists that rogue waves are the cause of many shipwrecks at sea. Now, seriously, think for yourself. When a ship gets into a storm, the captain reports it by radio and makes records in the logbook. But when a ship suddenly disappears from radar without any warnings about harsh weather, then it might have met a giant rogue wave. They're not tied to any particular location. They are sudden and unpredictable, and this makes them some of the greatest dangers in the ocean. So, what do we do now? How can ships, beaches, and oil production stations be protected? How to predict the appearance of a wave? Well, the answer is crest-trough correlation. It sounds incredibly difficult, but it's actually simple. The highest part of the wave is the crest. The lowest part of the wave is the trough. The idea is to measure how closely the ridges relate to the troughs. With strong correlation, waves form in dense groups. There are several regular waves and one or two large ones in the center. These conditions are ideal for the appearance of a rogue wave. Now, it seems obvious that scientists should use some instruments to measure the troughs and crests on the waves. It seems quite complicated, but in fact, these crest-to-trough correlations can be studied by watching the weather and currents. Scientists hope that they'll be able to predict the appearance of rogue waves using the same systems they need to predict the weather. So, you can take a breath. It seems we're safe. Or not. Given how the weather of our planet is changing, scientists expect an increase in wave height in the North Pacific Ocean. This will contribute to the appearance of giant rogue waves, even bigger than the ones people observed off the coast of Norway. How much bigger? 1.5 times? 2 and 3 times? Well, you better sit down. Scientists conducted experimental studies and found out that these waves can get 4 times larger than previously thought. Could the 85-foot-high wave recorded in 1995 be 4 times taller? It's hard to believe, but let's just imagine it theoretically. A rogue wave with a height of 340 feet may appear in the middle of a storm. This is more than the height of the Statue of Liberty from the pedestal to the tip of the torch. Such a giant wave can pull any ship underwater in a second and easily destroy an oil station. It can throw the Kraken or Megalodon out of the ocean like a stuffed toy. But how is it different from a tsunami? Well, a tsunami is born during seismic activity at the seabed. Such a wave grows, gains speed, and then crashes onto the shore. It's predictable, and you can spot it from afar. So let's hope that scientists will be able to predict the appearance of rogue waves in advance and warn ships not to sail into the risk zone. Ordinary people who live in coastal towns and relax on the beach are also at risk. In the future, they'll have to look not only at the weather forecast, but also at the risk of giant waves. Ocean waves can grow much bigger than we ever thought and be far more dangerous than we realized. People used to believe that waves only moved in two dimensions, just up and down, like when you draw them on paper. However, a recent study shows that waves are three-dimensional structures, able to move in different directions. This finding indicates that the ocean is more complex than we imagined, and today's ships, wind farms, oil rigs, and other structures near the coast might not be ready for what is coming. First things first, waves break. It might seem obvious, but the truth is that we don't fully understand how and why that happens, and don't know all the steps involved. What we do know is that when waves break, they change shape and become steeper. To better understand this process, researchers initially assumed that waves were two-dimensional. This assumption was necessary because it made it easier to study waves, whether in theory or through computer simulations and experiments. But here's the thing. Saying that waves are two-dimensional doesn't really capture what ocean waves are like. When most people think about waves, they imagine typical, non-threatening waves you see at the beach. But the ones we're talking about here happen in open water and form when waves coming from all different directions meet up. This wild meeting occurs under certain conditions at the ocean, like in a spot where two seas meet, or when winds suddenly change direction, like during a hurricane. When waves from two different directions come together, it creates this three-dimensional wave. To test how these unique waves behave and how they could make the ocean more dangerous for us, two researchers built a special tank, like a giant swimming pool, measuring 82 feet wide and 6.5 feet deep. All around this tank, they installed 168 mechanical paddles. These paddles act like giant hands, pushing the water back and forth to create waves, just like you would if you moved your hand through water in a bathtub. Stop the video and go do that right now. No, wait, I'm kidding. Anyways, the paddles can generate waves of varied sizes and shapes. Plus, they absorb incoming waves so that they don't bounce around the pool and mess up the tests. Beneath the tank, they put 28 huge fans that push water across the tank to simulate ocean currents, mimicking how ocean water moves. Altogether, they circulate around 2,400,000 liters of water in the tank. All of this was done to create a kind of mini-ocean, controlled by some really cool technology. Great! Everything was set, and it was time to test. The experiment has shown us that three-dimensional waves can become twice as steep as two-dimensional waves before breaking. Let me explain. So, the normal waves you see on the beach break when they reach a very steep angle. They have a limit, a maximum steepness, if you will. When that limit is crossed, the wave breaks. So, what this study is telling us is that waves in the open ocean can get as much as 80% steeper than this limit before they start breaking. That also means they can get almost twice as high as normal waves before they start to break. But the researchers found something else that was interesting. Normally, when a wave breaks, it creates a white cap, you know, that foamy part you see on top, and once it breaks, it's done. There's no going back. It's lost its energy. But when these multi-dimensional waves break, there is no white cap. They can only keep growing. That happens because the wave's energy isn't just concentrated in one direction, allowing waves to continue growing even after reaching the steepness limit when they're supposed to break. It's like these three-dimensional waves can redistribute energy and continue building up in the middle of the ocean. That means that together, these waves can grow 4 times steeper and larger than what we previously thought was possible. So, we are talking about bigger, massive waves that can suddenly appear in the middle of the ocean. It sounds scary to say the least. That's why, for our own safety, it's important to understand how this phenomenon occurs. Maybe buildings and homes along the beach aren't at such high risk from this, but these giant waves can pose a bigger threat to things that are in the middle of the sea, like oil rigs, wind farms, and boats. This finding raises significant questions about whether these constructions, as we design them today, are safe and could handle such extreme wave patterns. The thing is, sailors have been trying to warn us about this for centuries. In the 19th century, a French explorer named Jules Dumont d'Urville, I gave it a shot. He reported seeing rogue waves over 100 feet high during his voyages. Even though he was very experienced and respected, plus 3 other people confirmed that it had indeed happened, his story was discredited. Like this account, all other stories about massive and wild waves in the middle of the ocean were dismissed as myths, just tales sailors told to make their adventures sound more exciting. Hey, don't we all? Scientists only started taking these reports seriously in 1995, when a rogue wave was finally measured for the first time. The terrifying event happened at a gas platform in the North Sea, about 100 miles off the coast of Norway. The structure was built to withstand a wave of 64 feet, and even then, they thought a wave that big would only happen once every 10,000 years. But they definitely weren't ready for what happened on New Year's Day, when a monstrous 85-foot wave, 21 feet taller than predicted, hit the platform. In a more recent case from 2018, 8 men were on a 61-foot fishing vessel over 400 miles northeast of Hawaii's Big Island when they suddenly got hit by a pair of rogue waves. One hit the back of the boat and the other slammed into the side. It was too much to handle. A lot of water came over the top, flooding the boat and pulling it down to the depths. The crew had to abandon the ship and get into a lifeboat immediately. Thankfully, they were all rescued with no injuries at all. These are just a few examples showing that our current oil platforms and ships might not be prepared for massive rogue waves. That's why experts suggest that one solution could be for ship designers to make ships strong enough to withstand double the significant wave height. However, they'd probably need some convincing because of the increased costs. So, here is a pretty convincing fact. It's believed that between 2011 and 2018, 210 waves of this type were recorded around the world, but it's very likely that the real number is much higher. What triggers rogue waves is still somewhat of a mystery, but we know they are not caused by movement on the seabed. Instead, they seem to be more related to bad weather. In Tampa Bay, for example, most rogue waves come in from the west, especially when it's stormy or windy. But we can't say this is the main cause everywhere in the world, as experts believe there could be several other factors at play. What is really concerning is that rogue waves can strike without warning. The open sea can be completely calm when suddenly the whole scene turns into a fight for survival. So, can we actually predict this phenomenon? It looks like we can. In a very recent study, researchers created a computer system that uses measurements from buoys to predict unusually large waves 5 minutes before they happen. They can catch about 3 out of 4 rogue waves. While the system does have some false alarms, the researchers say that from a safety standpoint, knowing a rogue wave might happen is better than not knowing. And I think we can all agree on that. In November 2020, something terrifying happened in the ocean near British Columbia. Out of nowhere, a massive wave, as tall as a 4-story building, rose up and tossed a lonely little buoy way up in the air. Scientists later confirmed that it was the most extreme rogue wave ever recorded. Such a wave is so rare that experts think that something like that might only happen once every 1,300 years. Interestingly, if that buoy hadn't been floating there at just the right time, we might have never known this wave even happened. For a long time, people thought rogue waves were just sailor stories, something like scary tales passed around on ships. But in 1995, everything changed. On New Year's Day, a monstrosity of a wave 85 feet tall slammed into an oil platform off the coast of Norway. Scientists were shocked, since their models had never predicted a wave that big. That wave became known as the Doppler wave, and that was the first proof that rogue waves were real. Since then, scientists have spotted more of those giant waves, even in lakes. The one near a place called Ucluelet on Vancouver Island was special, not because it was the tallest, but because it was lots bigger than the waves around it. You see, to be called a rogue wave, a wave has to be more than twice as tall as the ones nearby. The Doppler wave was about twice the height of the other waves around it. But the Ucluelet wave? It was nearly 3 times taller than its neighbors. When scientists said this made it probably the most extreme rogue wave ever recorded. Now imagine a huge wall of water suddenly rising in the middle of a calm sea. That's the kind of ocean drama we're talking about. Very few rogue waves have ever been seen with human eyes, especially not ones that extreme. Scientists are still trying to understand how these monster waves form so that they can get better at predicting them before they strike. To do that, they track rogue waves in real time and run computer models to see how wind and water team up to create such powerful surges. Now, the giant wave off Ucluelet was picked up by a special buoy floating offshore. That buoy wasn't alone. It was part of a whole network placed out at sea by a research group called Marine Labs. Their goal is to learn more about the dangerous surprises the deep ocean can throw at us. Even when rogue waves happen far from land, they're still a serious threat. They can smash into ships, damage offshore wind farms, or wreck oil rigs. And if they come close enough to the coast, they can easily put people at the beach in danger, like it happened in April 2025 in Australia. Thankfully, the Ucluelet wave didn't hurt anyone, and neither did the famous Doppler wave before it. But other rogue waves haven't been so harmless. Back in the 1970s, some ships vanished without a trace. And now, scientists think freak waves might have been to blame. Bits of wreckage were sometimes found later. They were torn apart as if struck by a massive wall of water. Scientists think we could see more of these waves in the future, and this prediction is quite alarming. A 2020 study predicted that wave heights in the North Pacific might rise as the climate continues to change. That means the Ucluelet wave's record might not last as long as once expected. To make things even more intense, new research suggests these waves can be up to 4 times taller than scientists used to believe. And honestly, it sounds terrifying. Imagine sailing in the middle of the ocean and seeing a sky-high wall of water rising out of nowhere in front of your eyes. And rogue waves appear just like that, unexpectedly, unpredictably in the open ocean. While there's no exact size that makes a wave a rogue wave, they've been measured anywhere from 26 feet, like a 2-story house, to more than 80 feet tall. These waves are super steep, have sharp towering peaks, and can be strong enough to damage ships or oil rigs. But what causes them? That's where it gets tricky. There isn't just one thing that makes a rogue wave happen. They can form when different wave systems crash into each other. Think of it like a bunch of waves from different directions suddenly lining up just right, and boom! They combined into one huge wave that's way taller than usual. Other things can help too, like fast ocean currents, strong shifting winds, or certain underwater features like reefs or deep channels. Those can force waves into a small space, making them stack up. And still, when scientists know all these ingredients, rogue waves are still super rare and really hard to predict. Rogue waves aren't the same as tidal waves or tsunamis. Even though rogue waves can be just as dangerous, they occur for different reasons. Tidal waves happen because the moon and sun pull on Earth's water, making oceans rise and fall. Tsunamis happen when earthquakes, volcanoes, or big underwater landslides push giant waves across the ocean. Rogue waves, on the other hand, suddenly show up out of nowhere in the open sea. Big ships and oil rigs are built to handle waves up to about 50 feet tall. But rogue waves often get even bigger than that. That's why they can cause a lot of damage. For example, in December 2022, a huge rogue wave slammed into the cruise ship Viking Polaris near Antarctica. It broke windows, hurt some people, and sadly, even led to the loss of one life. Rogue waves have caused other accidents too. That's how dangerous they really are. These days, scientists know for sure that such waves happen way more often than you can imagine. I'm talking about one rogue wave for every 10,000 normal waves. Studies also show that waves have been getting bigger over the years. Still, rogue waves are tough to predict because we don't have enough information and they come up so fast. Now, even though rogue waves occur in the oceans all around the world, some places get more of them. One is near South Africa, where a strong current called the Agulhas flows. Another is the North Atlantic Ocean, where big currents like the Gulf Stream meet. Rogue waves have also been spotted in parts of the South Atlantic, Indian, and Pacific Oceans. But even if you live far away from those places, don't relax just yet. Rogue waves can happen in big lakes too. A famous example is the SS Edmund Fitzgerald, a giant iron ore freighter that sank in Lake Superior during a storm in 1975. The lives of all 29 crew members were lost, and a rogue wave might have caused the ship to sink. And that's not the only disaster caused by a rogue wave. Before scientists started measuring these waves, many shipwrecks had been mysteries. Now, some experts believe rogue waves caused some of them. For example, the USS Cyclops disappeared in 1918. The culprit could have been a rogue wave. Other ships, like the Norwegian tanker Wilstar in 1974 and the German freighter MS München in 1978, were hit by huge waves too. The Andrea Gale, a fishing boat lost in 1991, was probably sunk by a rogue wave too. Even modern cruise ships have been hit by giant waves. Rogue waves are, and were, quite popular among artists too. The famous Japanese artwork, Under the Wave off Kanagawa, shows a huge wave that many people think is a tsunami. But experts think it might actually be a rogue wave caused by wind. Rogue waves also appear in movies. For example, take the 2006 movie Poseidon. In it, a giant rogue wave hits a luxury cruise liner, which is making a transatlantic crossing. And as we see, it's something strange, unexpected, and way more mysterious than any other wave caused by the ground shaking. The sea is kind of rough today. Nothing special, but still, you have that sinking feeling in your stomach. Call it a sense of foreboding. Something bad is going to happen, and then you hear terrified shouts. You turn around and see a giant wave, much higher than the one surrounding it. Is it a tsunami? That's true. When people think of frightening, destructive waves, tsunamis are the first thing to come to mind. But the one that is going to crash against your ship has a different nature. It's a rogue wave. Both tsunamis and rogue waves can lead to catastrophic consequences, but the difference lies in what causes these walls of water and where the destruction they bring about occurs. So, imagine a giant 60-foot-tall wave rolling over your ship. It's a miracle that the vessel doesn't sink. This massive wave, a rogue wave, seems to have appeared out of the blue, very suddenly and unexpectedly. But however mysterious, solitary, and ominous rogue waves may seem, they're actually not that rare. Now, imagine the average room in your house. The ceiling there is likely 8 feet high. A typical 2-story house is somewhere between 20 and 30 feet high. And the Statue of Liberty is 111 feet tall if we measure it from the toes to the top of the head. Now you have something to compare rogue waves with. The largest of such waves can reach a height of 50 to 90 feet. To be considered rogue, a wave must appear seemingly out of nowhere and be higher than other waves in the area. But how much higher is still under debate. Some experts think it should be at least twice as high as other large waves in the area, while others disagree. Rogue waves are also steeper than regular waves, which normally take the form of massive swells. This allows ships to maneuver up and down such waves, even when they're really high. A rogue wave, however, looks like a wall of water, and since it's steeper than other waves, it slams into a ship with enormous force, sometimes breaking over the vessel. Another reason why rogue waves are a mystery is that no one has ever filmed the formation of such a wave and followed its life cycle. There are several photos of rogue waves, but for many centuries, the only evidence of their existence was legends and stories told by sailors who survived them. Scientists are still not sure how rogue waves form, but one theory involves wave reinforcement. It happens when two waves interact and their heights get combined. So when a 15-foot wave passes over a 30-foot one, let's do the math. It results in a short-living 45-foot wave. But rogue waves can occur not only in the ocean. On November 10, 1975, on Lake Superior, a group of 3 rogue waves, also known as the Three Sisters, might have sunk the SS Edmund Fitzgerald, an American Great Lakes freighter. The ship and the crew members were lost in the catastrophe. The waves followed each other too closely, so the ship couldn't recover and shed the water from the first wave before the following one struck. The captain of a ship that was not far from the Fitzgerald reported that his vessel had been hit by 2 30 to 35-foot waves. These waves, likely followed by a third one, then moved further in the direction of the Fitzgerald and might have caused the sinking. Now, let's wave bye-bye to that, and let's move on to tsunamis. It is an extremely dangerous natural disaster. It's very different from rogue waves. In most cases, a tsunami is caused by an underwater earthquake. Usually, when a tsunami is born, it's just a few feet high. But the closer it gets to the shore, the larger it grows. Soon it enters shallow waters and starts to slow down. The first tsunami wave crashes against the shore. Its top moves faster than the bottom, and that's what makes the wave so high and steep. The lowest point of the wave gets to dry land first. In the process, it creates a vacuum effect that pulls the water away from the coast, burying the harbor and seafloor. Those who recognize this first sign of an approaching tsunami still have a chance to save their lives. 5 minutes later, an enormous wall of water hits the shore and wipes out everything in its way. But it's not just a single wave, there are many. This phenomenon is called a wave train. How fast this train is traveling depends not on how far it is from the source of the waves, but on the ocean depth. Tsunamis can move as fast as a jet plane in the middle of the ocean, but once they enter shallow waters, their speed drops. The first tsunami wave isn't usually the strongest, but lots of people don't know it and make the grave mistake that sometimes costs them their lives. After the first wave is gone, they relax and believe the danger is over. That's why the next waves, much bigger and more powerful, catch them off guard. Now sometimes a tsunami comes as a torrent of foaming water. At other times, it makes the sea withdraw, leaving behind stranded fish and overturned boats. Also, if you spot a slight rise in sea level, it might be the sign of an approaching tsunami. The incoming water is the first tsunami wave. The second one can be even larger, and it comes sometime later. You can also notice seawater bubbling, swirling, and creating bizarre patterns. It's another sure sign a tsunami is near. Repeated wave surges can also warn you about a tsunami. If you see unusual swells coming at regular intervals, it might be time to evacuate to high ground. Surprisingly, some of the largest tsunami waves in the world were caused by landslides. For example, a landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. Its height was 1,720 feet. The mega tsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. When a third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean, it triggered a tsunami the size of one of the tallest buildings in the world, Shanghai Tower. The wave was around 2,000 feet high. Another bizarre and dangerous ocean phenomenon is square waves. They appear when two different wave patterns crash into each other at 90 degrees. It often happens near peninsulas or land where two different seas or oceans meet. This phenomenon does kind of look spectacular, but only if you're watching it from the shore. Don't even think about getting in the water to play with such waves. Cross currents in that spot can easily pull even a skilled swimmer under the water. Square waves have caused many shipping accidents over the years, too. And if you see wild, choppy waves carrying ocean debris and seaweed, stay out of the water, too. It can be a sign of a strong rip current. That can carry you far away into the ocean. And now, let me tell you about a much larger, I would even say planet-wide phenomenon called Rossby waves. There are two kinds of such waves, oceanic and atmospheric. But since we're talking about ocean waves, yeah. Slow-moving Rossby waves are totally different from ocean surface waves. They don't look like those waves that break along the shore. No, Rossby waves are giant movements of the ocean stretching horizontally across the planet. They can span hundreds of miles in a western direction and are so massive they can change the climate conditions of our planet. They contribute to high tides and even flooding in some areas all over the world. The movement of Rossby waves are complicated and depend on the location. For example, in the Pacific, waves that are closer to the equator take from a few months to a year to travel across the ocean. At the same time, waves further away from the equator often need more than 10 years to make this journey. So, as it goes by, be sure to wave.
Whoa, look at that view. It's a pity about the traffic. Yeah, we'll get a great view from inside the tunnel. What's going on? It's just a traffic jam. I don't know, but it doesn't sound good. Is that water? Yeah. It's probably rainwater. Although it is flowing pretty fast. There's water inside the car! I can't open mine. The water is too strong. Look, do you see that? The end of the tunnel. We're almost out. The current will carry us out. We're gonna hit in. I'm trying. What happened? Is that our car? That was too close.
Welcome to the virtual helicopter tour. We'll see the most picturesque sights of the city, although this place isn't real, and neither are its citizens.
Oh, wow! What a view! Whoa, it looks like a tsunami is coming!
Oh my cat, you're right! We should get out of here as fast as we can!
Please, tell me that this copter can handle a tsunami?
Don't worry, it's recommended to hide from tsunami waves at a height of at least 130 feet above sea level, and the record height that copters can reach is about 7 miles. Well, at least this city is just a simulation, and no one got hurt.
Hey, where did that fog come from?
It was formed when the wave hit the shore. By the way, the second wave may come soon, and the third one.
Then we should leave. But wait, can't we save those guys on the roof?
Of course. Hey guys, over here! Hurry up!
Seems like I'm safe here.
Nice to see you, honey. We didn't finish talking.
Ah! How did you get here?
You can't hide from me.
Challenge accepted. This roof looks good.
I'm gonna get you. Come on, come to mommy.
Leave me alone!
And speaking of moms, you forgot about my mother's birthday, empty head.
See you never.
Show yourself. Where are my flowers? Where is my gift for Valentine's Day? Why are you so lame?
Finally. She got lost.
Peekaboo!
Oh, well. What a wonderful day. Whoa! Did you see that? That was so epic! Wow! Alright, buddy. No time to think. Steal this car and let's try to survive.
Have you ever seen anything like this?
Not really. Look! The water's very close.
We need to get out of here. Now!
I'm doing my best.
Look out! Ah!
Hey!
Oh,
You okay? I didn't break a single bone.
we need to get to a safe space.
This is it!
Look out!
Hold on! We'll get out of here, I promise! Let's just try to run away from the waves. Hold on! I have a plan B. Oh no, plan B is canceled.
Whoa!
Alright, let's give it a try. Not so fast.
Yeah. We need to get out of here.
I have an idea.
Here we go!
Come here. It's all over. Oh, we're so lucky.
Ava! Another wave!
No! Look out!
Ah! It's too strong!
Help me!
This can't be happening! Ava! No! She's not breathing. I'll need to give her CPR. It's 30 compressions in the center of her chest. Then 2 rescue breaths. Come on. I thought I'd lost you.
We can't go back out there.
We'll need to find another way out.
Come on, this way. Stay close.
We need to be careful. We need to get to higher ground.
Oh no, get out of the way!
I'm not giving up. We need to jump. Let's get out of here. What a serene morning. Whoa, good heavens! The meteors! Hold on. I need to move, and fast!
I don't like this, but hope this route will work. Stay calm, buddy. All right, what's the next step? Seems like it's my only way out. Let's take this path. It's about to collapse. The world's falling in on itself. I need to reach fire escape ladder. Hope the worst has passed. Wow, that was a close call, thank heavens. I got to move on. Thank goodness. Oh God, it's falling apart! I'm okay. Gotta move on. What is that? A tsunami? Wow, this is definitely my day.
In 1945, 5 TBF Avenger aircraft took flight for a routine training exercise around the Bermuda Triangle. In the middle of the exercise, the planes were struck by intense rain and heavy winds, despite the clear weather forecast. The pilots became extremely disoriented and radioed the base to report that their navigational equipment had stopped working. The last thing the base heard was, "When the first plane drops below 10 gallons, we'll all go down together," and then static. The 5 planes and their 14 crew members were never seen or heard from again. On his very first voyage to the New World in 1492, Christopher Columbus sailed through the Bermuda Triangle. Columbus reported that one night when he was on the deck of the ship, he noticed a giant light appear in the distance, unlike anything he had ever seen before. Columbus looked at his compass for direction, and it gave off erratic readings. You might have noticed that the Bermuda Triangle doesn't appear on any world map. This is because official institutions refuse to acknowledge that the area actually exists. A popular theory suggests that rogue waves are responsible for the many disappearances. Rogue waves are called extreme storm waves by scientists. They occur when different weather patterns take place at the same time and cause large, unexpected waves. Witnesses say that the waves look like giant walls of water. These waves could explain why ships go down fast and without leaving any trace. The Bermuda Triangle is home to some pretty intense and unexpected weather. Storms build up quickly and unexpectedly. then disappear soon after. If you blink, you might miss it. This could explain why few distress signals are issued. Pilots and sailors never saw the weather coming. No one knows exactly how many ships and planes have disappeared in the Bermuda Triangle. The rough estimate is 50 ships and 20 planes. Most of the time, the disappearances had no explanation and no wreckage has ever been left behind. Another bizarre theory trying to solve the Bermuda Triangle mystery comes from Charlie Berlitz. He insists that the area is home to the lost city of Atlantis. The missing ships and planes and malfunctioning equipment, according to him, were all caused by rays of energy let out by the special energy crystals that power Atlantis. While this sounds silly, Berlitz's theory was convincing enough that over 20 million people bought his book worldwide. In the year 1800, a large sailing vessel called the USS Pickering departed from the U.S. on its way to the West Indies. The ship sailed into the Bermuda Triangle along with its 90-man crew and was never heard from again. The USS Pickering was the first ever confirmed ship to vanish in the Bermuda Triangle. It's believed that the ship was taken out by a storm, but because no wreckage was ever found, we'll never know for sure. When the TBF Avenger planes went missing, a massive search operation was conducted. Boats and planes searched the Bermuda Triangle for any signs of the aircraft. One of the boats searching was a PBM-5 Mariner airboat. The airboat took flight at 7:27 p.m. and called in a routine radio message 3 minutes later. Then, it was never heard from again. No trace was ever found of the rescue airboat or the 5 Avenger aircraft. An enormous investigation was launched into the disappearance of all these vehicles, but nothing was ever discovered. This particular area of the ocean is one of the most heavily traveled shipping routes in the world. Some skeptics believe that this fact solves the mystery. Statistically, the busier the area, the higher the frequency of accidents and disappearances. While this makes sense, it's not the frequency of disappearances that's responsible for the mystery of the Bermuda Triangle. It's the lack of explanation or wreckage found. On the ocean floor, decomposing organisms let off large concentrations of methane gas that gets trapped under the water. This gas can build up until, boom, it ruptures. The gas surges up to the surface and erupts. If a ship was in the area of one of these ruptures, the water would become much less dense and cause the ship to sink rapidly and without warning. Scientists believe this could be the cause of the many disappearances in the Bermuda Triangle. While this theory makes a lot of sense, it doesn't seem too likely. The U.S. Geological Survey has stated that no large releases of gas are believed to have occurred in this area for the past 15,000 years. The ocean floor is made of rocks containing a lot of magnetite. It's more like iron. Magnetic fields react to high concentrations of magnetite on the ocean floor, which may start a sort of conflict between the two. It can often lead to various weather anomalies and, as a result, navigation issues. And, naturally, any changes in the ocean floor or the Earth's magnetic fields influence the Bermuda Triangle a lot. Since the magnetic field is constantly moving, it might be also taking the Bermuda Triangle with it. Now that people know where the triangle is, it's easy to avoid it. It supposedly moves eastward together with the magnetic poles, but scientists still can't answer where exactly it will be in a couple of years. Some people blame all the disasters on the extraterrestrial paranormal activity. Others suppose it's all about raging natural phenomena. There's another triangle in Lake Michigan. Just like the one near Bermuda, the Michigan Triangle got its shady reputation for some disappearances. The first recorded one dates back to 1679. A large vessel, one of the largest of that time, set out on an expedition, yet once it got in the sinister triangle, it never came back. Much later, an aircraft disappeared in this triangle. The skies are usually very clear there, but back in 1883, some people witnessed abnormal things in the area. Some claim to have seen large blocks of ice falling from the skies, and the crew even managed to save one as hard proof. Meanwhile, the Pacific Ocean Mystery Area is another sinister triangle. Off the south coast of Japan, not far away from Tokyo, there's a sea where plenty of ships met their doom. disappearing without a trace in these waters. They call it the Devil's Triangle. Some scientists believe the cause of anomalies is the environmental changes. Also, there's a really high concentration of methane hydrates on the bottom of the ocean in the Pacific Triangle area. You're deviating from your original course and sailing in the wrong direction. There's the Caribbean Sea near the triangle, peppered with small islands. The seafloor here isn't deep. The ship can get in shallow waters. And now the ship is stuck on a shoal, and you have no idea where you are. If this were the 21st century, the ship's captain would be able to reach the shore using GPS and other modern navigation. But the most interesting thing is that the compass would work correctly this time, since the magnetic North Pole hasn't already coincided with the true one for a long time in the territory of the Bermuda Triangle. The agonic line is somewhere far away from here. There are no problems with navigation now, but for some reason, this is where ships disappear. In fact, not just here. Throughout the Atlantic Ocean, there are places where many more ships were gone. The Bermuda Triangle is not even in the top 10 of such places. One of the main reasons why many ships are lost here is that one of the most popular shipping routes in the Atlantic passes through the Bermuda Triangle. And the more ships in one place, the more shipwrecks. Simple probability. Then, it just starts getting weird. Other theories say that there's a space-time rift in this region. Ships and planes fall into this rift and end up in the past or the future. But for some reason, there's not a single proof of this myth. There's no reason to think that the rift is hidden somewhere here. The base of an extraterrestrial civilization is located in the Bermuda Triangle. Visitors from other galaxies steal sea vessels along with the crew, so no one finds the wreckage of the ships. This is also a popular myth that has no scientific justification. The Kraken lives somewhere in the triangle. It's a huge squid that sinks ships and also is a legend that sailors tell each other. However, gigantic squids live in the depths of the ocean. They can grow to the size of half a train car, but no cases have ever been recorded where they sunk a large vessel. And in the area of the Bermuda Triangle, they have never ever been seen. People in the past didn't know about the existence of these creatures, so when they saw them for the first time, they described them as huge, terrible monsters. Giant squids are some of the most elusive creatures on Earth, and scientists had to use sonar equipment to find them. They don't like to leave the dark depths and are likely to be afraid of the sound of any ship. So, that should squash the squid as a suspect. In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Dropner on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beats may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of three large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These three sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are two main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either, but putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters also have the power to move huge logs, which carries another hazard. The ocean is one of the most incredible places on Earth. It's not only beautiful, but also dangerous. We all know about sharks, huge octopuses, heavy storms, and the Bermuda Triangle. But there's something more terrifying and more dangerous than all of these things. I'm talking about rogue waves. The 4-passenger yacht Mignonette is sailing through the Cape of Good Hope in southern Africa. A storm blows through, but the yacht successfully survives it. By evening, the wind has completely subsided. The sea is calm. The team, tired after the storm, is going to rest. At this moment, seemingly out of nowhere, a 39-foot wave appears and crashes over the yacht with terrifying force. The yacht succumbs and sinks. Thankfully, the passengers escape in a lifeboat. For the next 24 days, they drift on the open sea until they're picked up by a passing ship. No one believed the stories of the surviving passengers about a huge wave. This story isn't a plot from a thriller movie, but a real event that occurred on July 5, 1884. Now imagine that you're sailing on a modern yacht in the open sea. The sun is shining brightly. There's not a single cloud. The sea is crystal clear and calm. What could be better than a vacation like this? Suddenly, you hear a very loud hum. In 2 to 3 seconds, a huge 33-foot wave appears from the calm surface of the sea and crashes into your yacht. Fortunately, the ship manages to stay afloat, and the wave disappears as suddenly as it appeared. This is also a real case that happened to the owner of the Calaran yacht on June 17, 2018. These waves have different names: white, rogue, wandering, monster. The French call them a bad joke. Unfortunately, there's nothing to laugh at. A meeting with such a wave usually ends with a sunken ship. Sirens, sea monsters, the anger of Poseidon. This is how people explain the appearance of massive waves in ancient times. Christopher Columbus was the first to write a note about a rogue wave as a natural phenomenon. In August 1498, his team explored the shores of West India, later America, when suddenly all of the crew members heard a deafening roar, and then a towering 88-foot wave appeared out of nowhere. Fortunately, the wave passed by, and Columbus went on his way. After that, a lot of reports were recorded about this phenomenon, but no one believed the sailors. Mermaids, kraken, and now monster waves? Come on, guys. This is the typical reaction to anyone claiming to have witnessed the nightmarish waves. Even when a 74-foot rogue wave suddenly fell on the British liner Queen Mary in 1942, the 15,000 people who lived to tell the tale were rarely taken seriously. Only in 1995 was the rogue wave officially recorded with special instruments. That day, an 85-foot wave hit the Norwegian gas platform Dopner. In order to study the nature of these waves, in 2000, the European Union created an international project called MaxWave. As part of this project, scientists launched 2 satellites to monitor the world's oceans. However, they ended up with more questions than answers. There's a special wave theory, according to which the larger the wave, the less likely it is to occur. Max wave satellites manage to record waves up to 82 feet. But here's the most interesting part. Such a wave should only appear every 200 years. But satellites discovered 10 monster waves in the first 3 weeks of operation. 19 years have passed since then, and we still know very little about it. The worst thing is that scientists have no ideas about how to predict the appearance of these waves in advance. Modern radars and sonars have recorded the proportions of these waves. Their height reaches from 39 to 164 feet. Their speed can reach 62 miles per hour, and their life expectancy is from 20 seconds to 2 minutes. Although information is scarce, scientists have managed to divide these waves into 3 types. The first type is the classic white wave. It appears not only in a storm, but also in a calm sea. After an unexpected appearance, it also suddenly dissolves into the water and leaves no residue. The second type is Three Sisters, and you guessed it, these are 3 consecutive waves, one of which is more massive than the others. Even a huge supertanker could break under the weight if caught in such waves. The third type is Wave Monster. Of all 3 types, this wave is the most dangerous and unpredictable. Imagine a 15-story building. The spectacle is certainly amazing, but I wouldn't want to see it in real life. Anyway, you can watch a lot of videos with rogue waves on YouTube, but after you watch our video. But what provokes these lonely waves? No one knows for sure. Perhaps rogue waves are of the same nature as tsunamis? Well, not at all. Tsunamis occur as a result of underwater earthquakes and grow as they draw closer to the coast. Some believe that they appear when the surface sea current encounters a strong headwind. Others are sure that the waves are born from the collision of warm and cold currents. Still others are convinced that it happens because of gravitational anomalies, when gravity sharply decreases or increases. There's also the theory of wave interference, small waves combining to form one big one, just like a snowball. But the most interesting theory is that waves form due to kinetic vampirism. Insert Dracula joke here. According to this version, under certain natural conditions, waves acquire the ability to exchange kinetic energy. And among all the waves, there will be one vampire wave, which will absorb the energy of the others. After accumulating enough energy, the vampire wave splashes it out. This theory explains the impact force and its sudden disappearance. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the most mysterious place in the Atlantic Ocean, the Bermuda Triangle. And while it's likely that rogue waves periodically appear there, it's impossible to consider them the main solution to the mysteries of the triangle. Besides ships, planes disappear there, and it's unlikely that the waves can reach them. Adding even more mystery to the phenomenon, these waves appear not only in the seas and oceans, but also in lakes. They were recorded numerous times in the Great Lakes. In Lake Superior, the largest of all the Great Lakes, the appearance of the Three Sisters has been recorded several times. In addition to rogue waves, sailors have told about a more terrible phenomenon, sea hollows. Imagine that this is a very big wave, but just the opposite. It goes under the water, forming a large dip in the sea. But unlike waves, such hollows have never been officially recorded. Rogue waves can be dangerous in a similar way by forming sea holes in the water. When the wave builds up, it draws in all the water around it, so near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. I think the Jaws movie should be replaced by a new film, Waves. Who cares about sharks now, when at any moment a wave the size of a skyscraper could come rushing towards you? Hey, anybody remember the movie The Poseidon Adventure? That was a rogue wave that capsized the ocean liner. There are no ways to anticipate rogue waves, but you can significantly reduce the risk of meeting one. Study the history and meteorological records of the area you want to visit. Most often, rogue waves are found off the east coast of Africa in the Indian Ocean and in the North Atlantic. By the way, it was there in 1985 at the Fastnet Rock Lighthouse that the highest wave ever recorded was captured. Its height reached 157 feet. If rogue waves don't scare you and you're determined to set sail, then watch for weather changes and, most importantly, look often at the horizon. Single waves can appear in the distance, so you have a chance to evade them. And if one narrowly misses sinking your boat, well, as it goes by, be sure to wave. Imagine a 10-story high wall of water with a foamy white peak smashing into the shore. That's the mental image we all have when we think of tsunamis. But is it accurate? And if it is, why don't daredevil surfers ride them? That's a huge wave begging to be caught. Fear of heights, top speeds, because they choose life? Don't want to smack right into a building when that thing crashes into the shore and floods through the streets? But they're supposed to be daredevils. And how cool would it be if you, with your cheeks flapping in the wind, could ride that tsunami right into your 10th floor apartment? Just don't forget to leave the window open when you head out. No, seriously, where would anyone get the idea to surf a tsunami? I know where. Movies. All those disaster flicks depicting tsunamis as monstrous waves. It's like they cut that wave from a summertime fun surfer movie, pasted it into their own, and blew the image way up. And don't forget about that blue-gray filter. There we go, our disaster tsunami blockbuster is ready. Leave it to the filmmakers to overlook the details. Realistically, the difference between tsunamis and surfing waves is as ridiculously huge as that movie wave about to take out that skyscraper. You can surf on a massive wave, as long as it's the right kind. And that surfable kind can even be bigger than tsunamis. Some surfers ride them every year, but I'll get into that a bit later. So, what is the difference between this right kind of wave and tsunamis? Well, in surfing, every wave has a face or wall. That's the sweet spot each surfer looks for to ride down from. Like going downhill on a snowboard, only you aren't strapped to the board and there's always an avalanche behind you. And there could be sharks right under your feet, waiting to clean up whatever's left of you when you wipe out. Sorry, that got a little, terrifying. Surfing's fun, but I'll watch from the beach, thanks. Tsunamis aren't like this at all. Imagine a tsunami more like a giant tide that comes in a matter of minutes. Yes, the water will likely rise 30, sometimes 60 feet higher than it usually does, but it won't do it as a wave with that much needed wall. It'll be something like a hill of water that rolls in. Think of it like a giant gloopy lava traveling over the shore, only faster. No, even faster. Wait, that's even more terrifying than the shark thing. Never mind. For a normal surfable wave to appear, all you need is the wind to blow. Tsunamis, however, are born by some relatively rare events like earthquakes and underwater volcano eruptions. This is also where the difference in force is coming from. Tsunamis aren't always bigger than regular waves, but they are much more powerful. So every time they come, they tend to bring disaster with them. When an underwater earthquake happens, it produces unbelievable amounts of energy that literally punches the water. This energy has to go somewhere, and that somewhere is towards the shore in the form of a tsunami. In fact, next time you're doing the dishes and in need of some fun, you can make your own mini tsunami. Just place your hand fully underwater and move it up and down, even just a little bit. You'll see ripples on the surface. This is what happens in the ocean after an earthquake, but on a much larger scale. Tsunamis gain incredible speed from the ocean bed moving or shifting up to 200 miles per hour. So those things hit land going as fast as an arrow through the air? Well, that's why I said cheeks flapping in the wind as you ride that gnarly wave. But no, seriously, they aren't going nearly that speed when they crash onto the shore. They lose a lot of that energy as they meet the rise of the ocean floor near the coastline and any underwater obstacle in their path. When you surf into your apartment window, you'll only be going about 30 miles per hour. They might slow down, but the wave grows bigger as it gets closer to the coast. Megatsunamis are those 100-footers that'll get you into your 10th floor flat. The average height for most is only about 10 to 30 feet. Yeah, only. Compare that to a normal surfing wave. It's usually 6 feet high and only goes about 13 miles per hour. That's why tsunamis are still fast and big enough to cause major damage. But the surfing ones are no walk in the park either. Those kinds can be dangerous too. Just like tsunamis, wind-driven waves will rise when they hit an underwater obstacle near the shore. This obstacle, be it an underwater ridge or coral reef, is the main source of danger for surfers. If a surfer can't hang, they'll be dragged into the deep where sharp reefs lie. That and hitting the water doesn't exactly feel like a gentle pat on the back for a job well done. Okay, I get it. You can't surf a tsunami. But we're in what-if territory, where the rules don't apply, and my imagination likes to run wild. So let's have some fun tackling this challenge. First things first. Since the tsunami isn't a usual wave, we need to find a way to turn it into a surfing spot. You know, somehow get it to form a wall. One thing that could work is an artificial obstacle under the water that'll be specifically designed to strip the tsunami of its monstrous energy. Sorry, we'll lose some of that epic speed, but we need to make it rise higher. The obstacle will have to be a massive structure, but still deep enough that our surfer doesn't bonk his head if he wipes out. Next, we need to take further safety measures. In this case, some sturdy gear. Typical surfing wetsuits are made of neoprene, a flexible material that can protect you only from cold water and help you stay afloat. But lucky you! A new technology recently emerged, a wetsuit that can resist a shark bite. It's like Kevlar vests in a way. All the tests show that it can't be punctured with sharp objects, and it prevents bones from breaking. Unfortunately, bruises from blunt impact are inevitable. It's tsunami surfing we're talking about after all. And finally, the board itself. If riding a normal surf wave is a fair challenge of your sense of balance, then keeping yourself on that board while riding a tsunami might just be impossible. Remember what if? Okay, let's throw some stabilizers on that bad boy. There, now you're ready. You're ready, aren't you? Don't chicken out on me now. Come on, people have done this. They do it all the time in Nazir, Portugal. Well, they don't surf tsunamis, of course, but big wave pro surfers go there every year to challenge Nazir swell. And this 30-foot tsunami you're about to ride is just a pup compared to the biggest wave ever surfed. It was 80 feet high, more than twice the height of a telephone pole. Brazilian pro surfer Rodrigo Coja broke this record in 2017. Maya Gabeira set the women's record by conquering a 68-foot wave in 2018. And I don't think that's the limit, because waves in Nazir can reach 100 feet at times. Hey, the reason why waves in Nazir are so big lies deep underneath the ocean surface. This place has one of the largest underwater canyons in Europe. It's a 140-mile-long, 3-mile-deep gash in the seabed that pushes insane amounts of seismic energy to produce massive waves by the time they hit the shore. The canyon alone triples wave heights here, but there's also strong ocean currents and powerful swell winds in this region. So, it's like the perfect storm for surfers who like a real challenge. An underwater earthquake opens a huge gap in the ocean floor. A large volume of water moves to fill the crack. At the same time, waves start to spread out from that point. They're just a foot high at first, but the closer they get to shore, the larger they become. When the waves reach shallow waters, they start to slow down. Their lower parts get to dry land first. This creates a vacuum effect that pulls the water away from the coast. The harbor and seafloor are visible now. And then, an enormous wall of water hits the shore. It wipes out everything in its path. Several minutes later, more waves usually arrive. Or it can be a landslide happening near a large body of water. Enormous amounts of forest, soil, and rock roll down into a lake or ocean, producing huge tsunami waves. Volcanic eruptions are responsible for 5% of the world's tsunamis. They can move great volumes of water and generate really big waves. Some tsunamis are caused by meteorites striking into our planet. If one of these red-hot space visitors strikes the ocean, the force of this collision displaces enough water to produce an extremely powerful tsunami. When a tsunami starts, its waves are usually just 1 foot high. That's what a small wave looks like. It comes up to the waist of the average person. Surfers call such rather big waves double overhead. The largest earthquake ever recorded happened near the coast of southern Chile. It triggered a tsunami that reached Hawaii, Japan, and the Philippines. The tsunami's largest wave was as tall as a 5-story building. The largest wave ever surfed was half as tall as the Arc de Triomphe in Paris. Garrett McNamara set this record in 2011 in Nazaré, Portugal. In 1995, scientists proved the existence of rogue waves, sudden unexpected swells. On that day, they saw an 84-foot wave. It was taller than the world's largest passenger plane Airbus A380. The giant was surrounded by smaller 20-foot waves. Tohoku tsunami waves in 2011 were generated by the strongest earthquake in Japan's recorded history. The highest wave was almost half as tall as the Brooklyn Bridge. Krakatoa's volcanic eruption in 1883 produced the loudest sound ever heard on the surface of the planet. The highest tsunami wave the eruption formed was as tall as the Statue of Liberty. April Fool's Day tsunami in 1946 was triggered by a powerful earthquake near Alaska. The tsunami's highest wave was a bit taller than the Colosseum in Rome. The Boxing Day tsunami started in the Indian Ocean in 2004. It was caused by a powerful undersea earthquake. Its tremors produced a series of tsunami waves. The largest of them almost reached the height of the Leaning Tower of Pisa. One of the most disastrous landslides hit Lodeland Valley in Norway in 1936. An enormous piece of rock, almost twice as large as the Eiffel Tower, broke loose and hurtled into Lofoten Lake. This caused an enormous tsunami wave. It was almost as tall as the Taj Mahal in India. 2017 Greenland Megatsunami was triggered by a massive landslide at one of the fjords. The waves that flooded the shore reached the height of Big Ben. A powerful volcanic eruption caused a landslide from a 4,000-year-old lava dome. This set off Unzen Volcano Megatsunami. The largest wave was half as tall as the Space Needle in Seattle. Fogo Megatsunami happened 73,000 years ago, when a part of the Fogo volcano collapsed into the sea. The megatsunami's largest wave was as tall as the Washington Monument. When the upper 1,500 feet of Mount St. Helens exploded, it caused a massive landslide. A part of this avalanche plunged down into Spirit Lake. This caused a wave that was more than half the height of the Eiffel Tower. The Vejont Dam megatsunami happened when a landslide dragged 9 billion cubic feet of forest, soil, and rock into the lake. A colossal wave overtopped the edge of the dam, taking out everything in its path. Its height was greater than that of the Golden Gate Bridge. A landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. The megatsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. A third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean. This created a tsunami the size of the second tallest building in the world, Shanghai Tower. It was April 2025 when geologists went back to Yellowstone's Norris Geyser Basin for the first time this year. And while doing their usual check, they realized that something was different this time. Where there used to be just a boring patch of ground, now there was a giant hole, about 13 feet wide, filled with weird, milky, light blue water. Everyone was terrified. Was it the sign that the Yellowstone supervolcano was ready to erupt? If so, it would be a worldwide disaster, the kind that destroys cities. According to the U.S. Geological Survey, if such an eruption occurred, the after effects would be felt all over the world. To start, the areas immediately surrounding Yellowstone would experience pyroclastic flows. That's the lava that erupts out of a volcano, including a high-density mix of volcanic gas, ash, pumice, and hot lava blocks. Those flows would destroy everything they touch, and an eruption of Yellowstone would send them into Wyoming, Idaho, and Montana. Areas further away from Yellowstone would escape the flows, but they would experience falling ash. It would come down heavily in the states closest to the epicenter. The ash would be especially dangerous for anyone breathing it in. The weight of the ash would also pose a serious threat. It would smother crops and collapse buildings as it piles up. Tragic consequences would be countless, but we'll talk about them later, because soon after the discovery, the weird pit surprised even experts. Geologists found rocks scattered everywhere. Some were about a foot across, and all of them were dusted with gray mud. This mud matched the walls of the new spring. It was like the place had simply exploded, but nobody had actually seen it happen. The team checked old satellite images to figure out when it appeared. In December 2024, the ground was totally normal. By January 6, 2025, a little dip had formed. And by February 13th, that water-filled hole was finally there. But the weird thing was that the sensors that usually pick up major hydrothermal explosions didn't detect anything. There was no giant blast or warning signs. Later, it turned out that this puzzling opening in the ground hadn't just popped up in one huge explosion. Instead, it formed from a bunch of smaller bursts over time. Little explosions first threw out rocks, then mud, and eventually created the pit. With time, it filled with silica-rich water. That was a huge relief for everyone. Yellowstone sits on a supervolcano, and its big explosions are a nightmare scenario. Luckily, this time, it was just a slow-building, small-scale explosion. It was dramatic, sure, but totally manageable. You see, Yellowstone National Park is full of geysers, hot springs, and all kinds of natural landscapes. But under the surface, things get incredibly intense, all because of the supervolcano. Now, supervolcanoes are often extremely large. They often have no cone at all, since they're typically the remains of gigantic magma chambers. Once, those chambers flared up, leaving behind a caldera. They're usually located over hotspots. It's no surprise that supervolcanoes can produce super eruptions, and when they do it, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes form when huge volumes of scorching hot magma escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. So, a pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more and more magma is trying to get to the surface. And then, bang, a super eruption occurs. Now, back in 2015, researchers at the University of Utah mapped out the main magma chamber of the Yellowstone supervolcano and were shocked by its size. And then, they found another one below it. Together, these underground magma pools could hold enough molten rock to fill the Grand Canyon 11 times. All that magma pushes up on the ground above, which is why Yellowstone rises about an inch or two every year. That slow lift might not sound like much, but combine it with the fact that Yellowstone is still an active volcano and has a volcanic explosivity index of 8, and it's enough to make you wonder what could happen if things went south. And yes, Yellowstone has indeed been a bit jumpy in recent years. In March 2023, there were 354 earthquakes in the area. Most were tiny, but the biggest hit a magnitude 3.7, part of a swarm of 106 quakes. Now, before you freak out, experts from the Yellowstone Volcano Observatory say there's no need to panic. No eruption is coming anytime soon. Volcanoes don't stick to a schedule. Just because Yellowstone hasn't erupted in a long time doesn't mean it's about to blow. The park is stable for now, but scientists are keeping a close eye on everything underground, the quakes, the rising ground, and even temperature changes, just to be safe. The superhot plume of magma, a hotspot under Yellowstone, has been churning for 17 million years. The Earth's crust slowly moved over it, making the hotspot leave a trail of volcanoes stretching more than 450 miles along the Snake River Plain. Most of those ancient ones are now buried under layers of lava and sediment. In just the past 2.1 million years, Yellowstone has unleashed 3 cataclysmic eruptions, so massive they managed to reshape the land. Each explosion sent pyroclastic flows, rivers of searing hot rock, ash, and pumice racing outward for miles. The debris piled up in layers hundreds of feet thick, some forming solid lava-like rock. When those eruptions emptied the underground magma chambers, the roof collapsed, forming the massive calderas we see today. Even after those mega eruptions, Yellowstone didn't stop. Between 180,000 and 70,000 years ago, enormous rhyolite lava flows, sometimes over 144 cubic miles, poured out. Some flows followed north-south vent lines. The West Yellowstone flow erupted around 110,000 years ago. The Nez Perez Creek flow followed 160,000 years ago. If you stand at Madison Junction on the caldera's northwest rim, you can see it, a cliff that formed when the Lava Creek Tuff eruption collapsed the land 640,000 years ago. And inside the caldera, you'll see the hardened lava flows snaking across the floor. Figuring out when a supervolcano might blow is like being able to read nature's warning signals. Thousands of years before a massive eruption, the heat underground starts building, and the magma chambers become like ticking pressure cookers. Little signs start showing up. Gas bubbles escape as the pressure shifts, and earthquakes shake the ground. The land above slowly rises. Cracks appear. Hot springs and geysers start acting up, heating even more than usual. Now, what would happen if Yellowstone erupted? Remember those pyroclastic flows we talked about before? They can contain 2 parts: the lower flow of the hot lava that moves at ground level, and a cloud of ash that follows above the lava level. So the 2 of them would devastate huge areas. The ash would even reach Europe within 3 to 4 days of the eruption, but it wouldn't be so bad there. After that, it would only take around 2 to 3 weeks before cooler temperatures set in around the globe, all thanks to the sulfur gas that would get to the upper atmosphere after the eruption. Scientists predict that global temperatures would drop by up to 10 to 12 degrees. These consequences could last for 6 to 10 years, putting an end to monsoons, which could cause widespread famine in Asia. Scared? Well, don't be. The good news is that scientists don't believe that the sleeping giant under Yellowstone National Park will wake up in our lifetime. Experts say the next Yellowstone eruption won't likely happen for hundreds of thousands of years. And even then, it may not be that bad, because scientists have discovered that the magma lurking within Yellowstone is actually split up amongst 4 different chambers. Not only that, but some of the reservoirs of magma are likely to cool down and solidify, lessening the chances of an eruption. So, while an eruption does sound like it would change the landscape of the world, it's very unlikely to happen anytime soon.
While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle, a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from 2 main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. And this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about 1/millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount Province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. Over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer, made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet. It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year. But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are 3 main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When 2 oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes. such as the 1906 earthquake that destroyed much of San Francisco. At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids: blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini-world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp, and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lahir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions. So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan. This was basically the deep sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot Sebastian and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, ice fish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic Circumpolar Current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future. The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help." Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level. And a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence. And when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the endgame here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first. About 2 billion years ago, a massive asteroid crashed into Earth, leaving behind total destruction and what we now call the Vredefort crater in South Africa. And get this, this space invader might have been way bigger than scientists originally thought, possibly twice the size of the asteroid that wiped out the dinosaurs. Nowadays, the Vredefort crater is about 99 miles across, which makes it the biggest visible crater on Earth. But technically, it's still smaller than the Chicxulub crater in Mexico. The latter is about 112 miles, and it was left by the infamous dinosaur distractor 66 million years ago. But the thing is, craters don't stay the same forever. Over time, erosion wears them down. That's why they start looking smaller than they used to. And scientists think that when the Vredefort crater first formed, it could actually reach 174 miles across. That means it was the biggest impact site Earth has ever seen, even though it looks smaller today. Just imagine how insane that impact must have been. A space rock that would have sent shockwaves ripping across the planet, triggered enormous wildfires, and completely changed the climate. The asteroid likely hit Earth at a very, very high speed. But since this catastrophe happened billions of years ago, way before dinosaurs or even complex life saw the light of day, it didn't wipe anything out like the Chicxulub asteroid did. At the same time, recently, researchers have realized that the asteroid might have been even bigger than they thought previously, up to 15.5 miles wide. As for the speed at which it slammed into Earth, it could reach a staggering 56,000 miles per hour. Now, figuring out how big Vredefort originally was, that's been a bit of a headache. The main issue is that it's super old, and we're talking about 2 billion years old. No wonder that over that much time, erosion has kind of worn it down, so it's hard to tell just how huge it once was. But it's not just erosion causing the problem. Over the years, new layers of rock have built up over parts of the crater, and they've covered up most of the original structure. That's why now only little pieces of the raised rim are left, and this makes it even harder to get a clear idea of how big it was. So, scientists started looking at the minerals around the crater, like quartz and zircon. They discovered that those were all messed up by the asteroid's impact. They had tiny fractures caused by the blast. Researchers studied those damaged crystals and managed to figure out how far the explosion actually spread. Equipped by this new knowledge, scientists now believe that their latest estimates of the size of the asteroid are the most accurate ones. The reason why we haven't heard much about this disastrous impact is that, unlike the Chicxulub asteroid, which wiped out the dinosaurs and reshaped life on Earth, the Vredefort asteroid hit at a time when Earth was a very different place. There were no trees, no animals, just single-celled life in the oceans. That means no mass extinction, no burning forests, no fossilized evidence of chaos. But scientists think it still had a massive impact on the planet. It might have changed the climate even more dramatically than the asteroid that ended dinosaurs. But since we don't have much direct evidence of the disaster, studying what's left of the Vredefort crater is one of the only ways to understand just how powerful this impact was. Even though it happened billions of years ago, learning about this impact can help us understand the history of our planet, and maybe even prepare for future asteroid threats. After all, they could be similar to what happened in Siberia at the beginning of the 20th century, pretty recently. It was a warm morning, June 30th, 1908, when the sky suddenly lit up with a blinding flash. What followed was an explosion so powerful that it remained a mystery for decades. Known as the Tunguska event, it was one of the most baffling disasters in history. Scientists suspected an asteroid impact, similar to the one that wiped out the dinosaurs. But there was one eerie problem. No crater was ever found. The explosion struck deep in the remote forests of Siberia, near the Podkamennaya Tunguska River. The blast was beyond anything seen before, flattening around 80 million trees across an area of 830 square miles. The sheer force of the event was mind-boggling. It was strong enough to devastate the landscape, scorch the ground, and wipe out countless animals. According to witnesses, there was an eerie glow in the sky, which was followed by a streaking fireball with an intense bluish light. It was brighter than the sun. Moments later, there was a deafening blast. The shockwave was so powerful that it shattered windows hundreds of miles away, and people were knocked off their feet. Yet, despite the destruction, the source of the explosion left no obvious trace. Later, scientists finally started to understand what had occurred on that day. Imagine a meteoroid racing into Earth's atmosphere, transforming into a blazing meteor. It's traveling so fast that the air in front of it compresses and heats up, setting it on fire. But it's so large that it doesn't just burn up all of a sudden. it explodes. When that happens, the blast releases so much energy that a powerful shockwave spreads out. And since the explosion happens in the air, it leaves no impact crater. Back in the early 1900s, with limited technology and the remote location, scientists were left with a puzzle. Only much later did they eventually conclude it had been an airburst, where an object explodes high in the atmosphere, never striking the ground but releasing enough energy to devastate the area. Most likely, it was a giant asteroid about the size of a 25-story building. It could have been moving at around 33,500 miles per hour and exploding about 3 to 6 miles above Earth's surface. Another wild story happened back in the late 90s, but it wasn't Earth that was affected. A comet got stuck in orbit around Jupiter. One day, it got too close and Jupiter's immense gravity broke it apart, turning it into a bunch of pieces. Some of them were as big as half a mile across. Scientists were curious because they didn't know what would happen when those pieces hit the planet. And in July 1994, the moment came. The comet's broken up pieces started crashing into Jupiter, one after the other. Over 6 days, 21 chunks of the comet smashed into the planet at insane speeds, like 37 miles per second. That's more than 130,000 miles per hour. The impacts were so powerful that they heated up Jupiter's atmosphere to a mind-boggling 53,000 degrees Fahrenheit, which is way hotter than the sun's surface. When each chunk hit, it sent massive plumes of material flying out of Jupiter, like when you throw a rock into a pond, but way bigger. Some of these plumes shot up almost 1,900 miles into the sky. Afterward, big dark scars appeared in Jupiter's atmosphere, and they stayed visible for months as the debris spread out across the planet. But this wasn't just a cool space event. Scientists actually learned a lot from it. Those dark impact marks helped scientists track the winds in Jupiter's stratosphere. The crashes even caused temporary changes in Jupiter's glowing auroras, showing that the planet's magnetic field was affected by particles from the explosions. Plus, the comet fragments didn't just make a mess, they also left behind new chemicals in Jupiter's atmosphere. Plus, some chemicals were also exhumed from the lower atmosphere. Some molecules like ammonia broke down over time, but others like hydrogen cyanide and water are still floating around Jupiter today. This helped scientists understand how different chemicals react and mix in Jupiter's atmosphere. Comet Shoemaker-Levy 9 was a wake-up call. It proved that massive space collisions still happen in our solar system. That's one big reason why NASA started looking into how we can track and prepare for any future impacts that might threaten Earth. Whether it's learning more about asteroids and comets, or about how giant impacts shape planets, the importance of such discoveries is undeniable.
Oh look, there's a giant blob heading straight for New York City. Oh wait, hold on. You'll actually have to look down, not up, because this blob is a mass of hot rock moving beneath the Earth's surface. And when it finally reaches the Big Apple, some say it could tear the continent in two. But Yankees fans, and even you Mets fans, don't worry, this journey is going to take about 15 million years or so. You see, a long time ago, people noticed something curious. When they looked at world maps, they thought, don't the continents look like puzzle pieces that could fit together? That couldn't just be a coincidence, right? Then, in the year 1912, a German meteorologist named Alfred Wegener came up with a revolutionary idea, something we now know as the theory of continental drift. Wegener said the continents are always on the move, and those huge chunks of land we see today were all once connected, forming one giant supercontinent called Pangaea. That idea suddenly explained a lot of mysteries, like why fossils from the same species turn up in different corners of the world, even though entire oceans lie between them, or why coastlines of continents match up so neatly, just like South America and Africa. Wegener also explained that mountains form when a drifting continent runs into another one, crumpling the land and pushing it upward. That is exactly how the Himalayas came to be. The Indian plate collided with the Eurasian plate, and the land rose into the massive mountain range we see today. Now these days, everybody learns about Wegener's idea in school and takes it as fact. But back then, many people thought he was completely out of his mind. I mean, whole continents moving around? What on earth could push them? That's why it took scientists more than 50 years to finally go, oh, I see, it's the Earth's mantle. Yep, slow-moving currents of hot rock deep in the Earth's mantle push the tectonic plates around, and that means the continents move too. Picture super tough puzzle pieces floating on top of boiling oatmeal. That's a picture. Yep, they drift, and sooner or later they crash into each other. This is what happens on Earth's surface. And that's how we finally agreed that Wegener was right. But what if I told you that might not always be the case? Some experts agree that the supercontinent Pangaea started breaking apart about 200 million years ago. And that's how we ended up with the world map we know today. But a recent study is challenging part of that idea. And it all comes down to a giant mass of hot rock, something scientists call the Northern Appalachian Anomaly, or just NAA. Yep, what we casually call a blob, the experts call an anomaly, and that is simply because it is hotter than the rock around it. So this anomaly sits about 124 miles beneath the mountains of New England and stretches up to 249 miles wide. It lies in the asthenosphere, the semi-molten layer of Earth's upper mantle. But here's the strange part. It should not even be there. I mean, rock formations like this normally don't exist in that part of Earth's interior. For years, scientists thought the anomaly was left over from when the North American continent broke apart from Northwest Africa about 180 million years ago. This new study says that might not be the case. It suggests the blob is actually linked to the process that split Greenland from North America only about 80 million years ago. The idea then is that this blob is a leftover from when the landmass broke apart, a piece that never quite settled down. This is one stubborn blob we're talking about because it is still on the move, super slowly. But still, it moves only about 12 miles in a million years. Over time, it's already traveled more than 1,100 miles from where it first appeared. And now, New Yorkers, watch out! This blob of scorching hot rock is heading your way. Okay, I know, I'm being a little dramatic. The truth is, we really don't have to worry. First, scientists say it won't even get near the city for at least 15 million years. And second, even though we call it a blob, it is not something gelatinous. It is not oozing. And it is definitely not going to push its way up through the Earth's crust and invade the New York subway, or anything like that. That is just not going to happen. What the anomaly will look like, or what it might do to the continent in the future, is still a mystery for geologists. But they are pretty confident it will not have any real impact on human infrastructure or on our daily lives. It is not like lava that's suddenly going to burst through the floor of your house. That's because, at the end of the day, the blob is just rock. Like any rock you see on the street, only super high, enormous, and buried deep inside the Earth. To explain why this rock is sitting in such a weird spot, scientists came up with what they call the mantle wave theory. So think of it kind of like a lava lamp. After continents break apart, hot, heavy rock can detach from the bottom of the tectonic plates in blobs. These blobs, or pieces of rock, move around under the crust and create waves. When that hot material slips under a continent, it works like the flame under a hot air balloon. It gives the land a little lift. Then, when continents stretch and split, space opens up underneath and semi-molten rock quickly fills in. Eventually, it cools down, gets heavier, and sinks. Meanwhile, hotter mantle material rises up and creates a warm patch called a thermal anomaly. This sudden motion shakes up the base of the continent. Imagine a row of dominoes. One piece falls and the rest follows. Blobs of rock start dripping downward one after another, and over time, they slowly move inland. Scientists think these rock currents keep flowing, rippling under the surface for millions of years. Now, knowing all this matters because the anomaly might have played a role in shaping the land above it. For example, It may have lifted up some ancient mountains over the past few million years. That helps to explain a big mystery of the region: why the Appalachians are still standing. I mean, why haven't they worn down as much as you would expect after all this time? Well, think about it. The Appalachians are ancient. This mountain range in North America started forming hundreds of millions of years ago, long before the dinosaurs. With all that time, rain, wind, and erosion should have worn them down to almost nothing by now. Honestly, some geologists expected them to be rolling hills at best. But nope, they're still mountains, pretty ones too, and much bigger than they should be. And here's where the blob comes in. See, when a giant pocket of superhot rock sits under a mountain range, it can actually give the crust a little lift. It's kind of like putting a balloon under a blanket. The blanket rises up. The heat makes the Earth's crust lighter. So even while wind and rain are wearing the mountains down from above, the Earth is gently pushing them back up from below. There is another positive takeaway from this study. These new insights can help scientists better understand other strange geological features around the world. In fact, the researchers believe they may have already found a twin to this blob, sitting under north-central Greenland and also tied to the Labrador Sea. So, what can we conclude from all this? Well, tectonic plate movement is still the reasons continents break apart. But the process goes much deeper than we thought. The effects of ancient rifting can still play out millions of years after the surface split, just like what happened in Greenland. Although it's still really hard to predict what this anomaly will look like in the future, we know one thing for sure right now: there is nothing to fear, and I'm betting that most of us won't be around for that. Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring axial seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So, here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes axial seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, axial seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, axial seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where two major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where two tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial's summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler, well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When Axial erupts, it's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial's eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding Axial's patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front row seat to a natural fireworks display, thousands of feet beneath the waves. The livestream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale. Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now, since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So, the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Tsunamis eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity. and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sunthunkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions.
Frankenstein, unreasonably cold weather, and tons of lava. What do these things have in common? They all trace their origins back to Mount Tambora. This volcano in Indonesia had such a massive impact that the aftermath could be felt in Switzerland even a year later. And these spots are thousands of miles apart. Soon, we might be facing something similar again. Stick around, because I'm about to reveal the exact spot where the next eruption is expected to happen in 2025. Back in 1815, Mount Tambora erupted with unprecedented force, sending a colossal cloud of fine particles into the atmosphere. This cloud reflected sunlight, leading to global cooling and even the year without a summer in 1816. Temperatures plummeted, crops failed, and families worldwide faced food shortages, compounded by various health issues. Fun fact: Frankenstein appeared because of abnormally cold weather in the summer of 1816. The author got stuck indoors in Switzerland and wrote this story to pass the time. But that is the only positive aftermath. In England and Ireland, people struggled to find food. The crops were too bad that year, and this year without summer cost them lives, all because of the eruption in Indonesia. While many other volcanoes have erupted since then, none have had consequences as dramatic as Tambora. However, climate professor Marcus Stoffel from the University of Geneva believes potential serious eruptions aren't just a matter of luck, it's only a matter of time. So it's up to us. We can sit back and wait for the inevitable, or we can start preparing today. This future eruption will happen in a world that's vastly different from the one in 1815. Not only is our planet more densely populated now, but we've also experienced irreversible changes that affect our daily lives. Now, if you think volcanoes are always the bad guys, think again. They've actually played a crucial role in shaping our planet. They help with land formation, atmospheric development, and climate modulation. Just look at Yellowstone, for example. When thick lava oozed to the surface, it spread across the landscape and transformed the area forever. When volcanoes blow their tops, they release a mix of lava, ash, and gases, including carbon dioxide. But don't worry, compared to the emissions from fossil fuels, the amount from volcanoes is pretty tiny. What scientists are really keeping an eye on is sulfur dioxide, because it can have a big impact on our climate. When a major volcanic eruption happens, it can send sulfur dioxide soaring into the stratosphere, which is about 7 miles up in the atmosphere. Once there, it transforms into tiny aerosol particles that scatter sunlight, helping to cool the planet. This cooling effect isn't immediate though. Those particles can hang around for a couple of years and even circulate all around the globe. Nowadays, we've got special equipment to monitor sulfur dioxide emissions from space. Take Mount Pinatubo in the Philippines. During its eruption in 1991, it released around 15 million tons of sulfur dioxide. Now, while that's a lot, it wasn't quite as massive as the eruption of Tambora. Still, Pinatubo managed to lower global temperatures by about 0.5 degrees Celsius for several years. Tambora, on the other hand, dropped average global temperatures by about 1 degree Fahrenheit. I know what you might be thinking. That's not much, but trust me, it makes a difference. If the planet warms up by just 1 degree Fahrenheit, it could really mess with sea levels. Experts think we might see a rise of up to 8 inches by the end of this century. This could wipe out a lot of farmland and coastal habitats. which would be a huge blow to many communities. So maybe a volcano eruption that can cool off the planet is like a natural mechanism helping us out? Not exactly. While it does cool the planet off, don't get tricked into thinking it's the kind of coolness our planet needs. Such temperature shifts can severely mess up with the crops, like they did in 1816. There's also evidence that major eruptions can disrupt rainfall patterns, leading to drier conditions in monsoon regions across Africa and Asia. You see, the summer monsoon relies on the temperature difference between land and ocean, which can be altered by volcanic activity. Interestingly, a warmer climate may enhance the cooling effects of volcanic eruptions. Experts explain that the formation and movement of aerosol particles depend on climate conditions. As global temperatures rise, faster air circulation can lead to smaller aerosol particles, which are more effective at scattering sunlight and thereby intensifying the cooling effect. Oceans also contribute to this dynamic. A warming ocean surface creates a stratified layer, hindering the mixing of warm and cold water, which could mean that volcanic eruptions primarily cool the upper ocean layer and the atmosphere above it, according to Stoffel. Moreover, climate change may influence volcanic systems directly. The melting of ice can trigger more eruptions by reducing the pressure that allows magma to ascend more easily. Additionally, increased rainfall associated with climate change can seep into the ground and interact with magma, potentially sparking eruptions. While the prospect of a cooling period due to a volcanic eruption might seem beneficial amid climate change, scientists warn that the effects could be dire. The immediate consequences could be severe, particularly for the estimated 800 million individuals residing near active volcanoes. A major eruption could devastate entire cities. For example, Campi Flegrei, located near Naples, Italy, is showing signs of increased activity and threatens the lives of about 1 million people. Now, if you're from Oregon, beware, as experts say this state might experience volcano eruptions. Are you scared? Don't be. It's actually not as scary as it seems. Let me explain why. There are more than 80 volcanoes in Oregon, but we're not interested in a single one of them because it's an underwater volcano that is likely to erupt in 2025. Axial Seamount is the most active volcano in the Pacific Northwest, yet it remains largely unknown to the public due to its location approximately 300 miles offshore and nearly a mile beneath the ocean's surface. While its upcoming eruption is expected to pose no threat of a tsunami or significant land-based earthquakes because of its depth and distance from the Cascadia Fault, the data gathered from studying its eruptions can enhance our monitoring of potentially more hazardous volcanoes. Let's call it a friendly eruption, shall we? In reality, predicting eruptions is a complex endeavor. We often encounter alarming headlines, such as, "Yellowstone is about to erupt." Should we take these claims seriously? Not really. Yes, Yellowstone sits atop an active supervolcano that has experienced 3 major explosive eruptions in the past 2.1 million years. The last eruption occurred approximately 70,000 years ago, with the most significant explosion taking place around 631,000 years ago, forming the massive Yellowstone caldera. Naturally, many people are curious about whether Yellowstone will erupt again and when that might happen. Fortunately, scientists are employing new techniques to delve into these questions. A recent study suggests that Yellowstone is unlikely to experience another major eruption anytime soon. The reason is that the magma beneath the park is divided into a network of separate chambers. While there is a substantial amount of magma present, it's not sufficiently interconnected to support an eruption. Previous studies proposed that the existence of a massive layer of magma beneath Yellowstone, but these latest findings change that notion. To gain a clearer understanding of the subterranean dynamics, researchers utilized a technique called magnetotellurics, which employs Earth's natural electromagnetic fields rather than seismic waves. Since magma is a good conductor of electricity, This method is particularly effective for mapping molten rock and comprehending underground activity in volcanically active regions. By using magnetotellurics, scientists created a detailed map of the magma under Yellowstone, enabling them to make more informed predictions about future eruptions. But what will happen if an eruption similar to Mount Tambora occurs? By and large, there will be huge climate chaos. Yeah, the best scientists are looking for the solution should it really happen, but they don't have it yet. So technically, we're not ready for the second Mount Tambora. But for now, we're pretty much safe. No major eruptions are predicted. Whew!
So, some scientists drilled through the seafloor off the U.S. East Coast only to find more water. But this time, it's the kind of water we can actually drink. And that's a big deal, because this new freshwater reservoir could supply a metropolis the size of New York City for the next 800 years. Now, the team is confused. They're trying to figure out how a giant freshwater system ended up under the ocean, and more importantly, how it stayed hidden from us for over 20,000 years. Okay, to be fair, scientists have suspected there's fresh water under the seafloor since the late 1960s. But only recently, researchers actually got on a boat to follow up on those reports. They named the mission Expedition 501, and they had one goal: drill to the bottom of the ocean and see what was really hiding down there. So those scientists drilled about 1,300 feet down off the coast of Massachusetts, and once they got that deep, they hit a thick layer of sediment that was basically soaked with fresh water. Now, that freshwater layer sat below the saltier sediment, and above it, there was a tight lid made of clay and silt, material that doesn't really let water pass through. This seal is strong enough to keep the two layers separated. So, up top, you got seawater, and down below, fresh water. The drilling process took about 3 months. In that time, they pulled up 13,200 gallons of water from 3 different spots beneath the seafloor, just off Nantucket and Martha's Vineyard. They're still analyzing the results, but early reports suggest this reservoir might be much bigger than they previously thought. It could stretch from offshore New Jersey all the way north to Maine. Now, despite its size, it did a pretty good job hiding from us. Now, scientists are trying to figure out when and how this reservoir was formed. And back in 2003, one study suggested fresh water could get trapped under the ocean in at least 3 different ways. Theory number 1: tall mountains near the ocean can funnel rainwater straight down from higher elevations and into the seabed. Theory number 2: a hidden reservoir can form if sea levels stay very low for a long time and rainwater seeps into the ground. Then, when sea levels rise again over hundreds of thousands of years, that fresh water can get trapped in the sediment underneath. And theory number 3, which is connected to the one before, is that a freshwater reservoir can form under the ocean when ice sheets grow and sea levels drop. At the bottom of the ice sheet, the ice slides over solid rock, known as bedrock. As the ice scrapes and grinds against this rock, it creates heat, which melts some of the ice. That melted water collects at the base of the ice sheet. Then, because the ice is extremely heavy, it pushes the water down into the ground. Over time, the water gets trapped under layers of sediment. Well, more than 20 years later, scientists are finally close to an answer. The mountain theory is basically ruled out here because of the geography of New England. There are no large high mountain ranges right next to the coast. But the glacier theory could make sense. Their hypothesis is that the fresh water in this reservoir came from glaciers at some point during the last ice age, which lasted from about 2.6 million to 11,000 years ago. Still, it's not a final answer. The team is now studying the reservoir in much more detail. They're still analyzing things like microbes, rare earth elements, and the pore space in the sediment. All of that can help researchers estimate the reservoir's size more precisely. The age of the sediments can also narrow down when exactly it formed, and knowing its origin will help reveal how those systems have evolved over time. We just have to wait a little longer. But one thing is certain, there really is fresh water under the ocean. And when you think about that, it's hard not to wonder, wouldn't some salt get mixed in? And yeah, that can happen. So let's take a look at the map. Here's the reservoir. The farther you go from the coast, the saltier the water gets, and that doesn't matter much to us because it's not safe to drink anyway. But the closer you get to the coast, the less salt there is. The drill site closest to Nantucket and Martha's Vineyard showed that out of every 1,000 parts of water, only 1 part is salt, so it's considered safe. You can drink it, cook with it, and take a bath in it. But why does all of this actually matter? Well, because fresh water is becoming a big problem around the world. I mean, the lack of it. A new United Nations report talks about a global water bankruptcy. They say we've hit a new and pretty worrying stage. More and more river basins and underground water sources, called aquifers, can't go back to their historical normal. Droughts and shortages are becoming more permanent, completely changing what life looks like in some places. For example, the Aral Sea. This was once the world's 3rd largest lake and looked like this back in the 1980s. And this is how it looks today. It's completely dried out. It's not just there. More than half of the world's large lakes have lost water since the early 1990s. And Central Europe has lost 39% of its glacier ice in little over 20 years. So even now, over 1 billion people around the world still don't have access to fresh water. And estimates say that in just 5 years, demand will be 40% higher than supply. That's why this finding is such a huge deal. It doesn't mean we're about to start pumping water from under the ocean tomorrow. But it does mean we might have backup options in the future, especially for big coastal cities. That's exactly the goal of Expedition 501. And it's not just in the U.S. This group is part of a much larger international science program called the International Ocean Discovery Program, or IODP. Their goal is basically to drill deep into the seafloor to understand how Earth works, its climate, its geology, and in this case, its hidden water systems. This expedition came after decades of unanswered questions. Like we mentioned earlier, researchers had hints of fresh water under the seafloor for decades. Those hints came from strange electromagnetic signals and seismic data. But back then, the technology just wasn't good enough to confirm it. So the idea stayed on paper for a long time. Everything changed when modern drilling came into play. Expedition 501 literally drills straight down through the seafloor and pulls up sediment samples. And this process normally takes days to months. Is it safe, though? Well, they say the ship that carries the drilling rig follows international rules to protect the environment. They're also taking every precaution to make sure no solid or liquid material is dumped into the sea during the work. Their new finding off the East Coast is only the beginning. For now, it's the largest one of its kind. But scientists believe there may be still many hidden reservoirs out there around the world. Similar expeditions are planned or already happening near other parts of the world. Soon, scientists might find new reservoirs off the coasts of Indonesia, Australia, and even South Africa. So, Expedition 501 is basically about mapping these hidden freshwater reservoirs and finding out how they form, how stable they are, and whether we can protect them. Because, yeah, they still have a huge technical problem ahead, which is making sure the fresh water doesn't mix with the salty water above and below it. And that really matters if we ever want to use this water in the future, or avoid contaminating aquifers that already exist near the coast. So this expedition is pushing scientists to find answers to a pretty uncomfortable question. If fresh water gets harder and harder to find, what options